So till now, what we have seen in the previous classes, we have seen entire thing, a quick recap we will do that as per the syllabus, we are moving on. So first thing what we have seen is what is in Boolean algebra. What we have seen that we have three basic gates. The in output of that gate is used to create Boolean expressions. And based on that are the why, then these expressions have been converted with the help of your Boolean laws so that the end result of the entire equation is a smaller equation, right? So with the help of logic gates, that is these three basic gates, that is OR, NOT, and NAND, we are actually creating a circuit. But after creating the circuit, we are reducing it with the help of Boolean expressions and Boolean postulates so that the end result of that entire equation is in the reduced form. So what advantage do we get with that? The advantage that we had is that we can just take universal gate to make that entire circuit. What is universal gate? Basically, universal gates can, it's like a one particular type of gate, and by just having some permutation combination of these gates, we can go ahead with all the five operations of multiplication, that is and, then
Ma'am,
addition. Yeah, what happened?
your voice.
When we say the combinational gates, the main aim is that we are talking about a particular operation. See, and is multiplication or is addition, not is complementary. These are the basic functions. Now, when we use all these functions and all these gates to get a specific output, we call it as a combinational gate. But the advantage that we have here is we can create an IC out of it. Like here, if you see this A B bar plus A bar B, this is a combination of all three gates, but we can just put it in an IC and we can call it XOR gate. Same way we are doing with XNOR also. If you see here again, what we are having is A bar, AB plus A bar, B bar. Again, all three gates are being used here in a combination, but we can put it in an IC and we can use it for XNOR operation. Or what else can we do? We can use XOR gate, put a NOT gate in front of that, and we can use it as XNOR. So the advantage of these combinational gates is wherever you want to use all this, see how many gates are there. If you see 1, 2, 3, 4, 5. So wherever you want to use this 5 gates, instead of 5 gates, you're just using an IC. That is the advantage of XOR gate. So these three basic gates can be combined together to get a combinational gates, that is XOR and XNOR. Also, these basic gates can be combined to get universal gates. Now, why we use the term universal? Because what we have seen is with these universal gates, we can actually get into all five operations. What are the five operations we can do with universal gates? It universal gate can be either and, all ands, or all nots. We are not talking about and nor. We are talking about and altogether. We are talking about nor altogether. That means only one type of universal gate we are using at a time to get an operation. So all five operations can be done. So three to we know, and or and not. Other two are XNOR and XOR. So they all come as an operations, and with the help of this single one type of single type, I'm saying, okay, number of gates can be more, type is same, that is either NAND, all NANDs, or all NORs. Is it clear now?
Yes, ma'am.
Thanks for asking. Okay, let's move on. Now, that's what we have seen about the XOR NOR and how a number of gates can be increased with the help of these, how the number of different type of operations can be created with these gates. Now, like here, you can take the example what we were talking about. That see, with only one type of universal gate, we are able to go ahead with the operation of NOT, with AND, with OR, with here XOR and XNOR. All five operations we are able to do it. Then we have seen how to solve these questions, right? Then now we will come back to that one thing what we have understood with the help of all these things what we have studied till now, we can reduce the equation into a smaller part, right? That's what we have done here. Here what we did is, see, if you go ahead, here what we did, where we were using so many number of gates, we have just reduced that entire equation. You can use any postulate, and we have reduced the number. So here with this circuit also you are getting the same output of X, and with reduced form also you are getting the same output of X. That means by reducing the number of gates, we have reduced the complexity of the circuit, whereas output is not been changed, or output is not suffering. So that is what we have done with Boolean expressions and Boolean logic. Now, if that is okay, if the number of gates are only 3 or number of inputs are 3 or 4, but if the number of inputs keep increasing, like if you go for the complicated circuits, you will not find only 3 or 4 inputs. There are many inputs. First, the input that has been received, after that, lot of processing is happening, and then you are getting the output. If you try to solve it with what we have done till now, that is with the help of Boolean expression, the circuit will be very long. The time taken to solve that circuit will be also very long. So this Karnaugh, one person, one scientist, he has found out one thing, that if I express everything in a tabular form, and he has found a way of solving it, then you can find that solving is easy, very less time, less complicated, and result is the same that we were expecting. So before doing that K map, what he did, that Karnaugh first converted this entire Boolean expression into truth table. So there are actually two ways of representing the truth table. You know what is a truth table, right? Truth table is, when we have inputs, say 2 to the power of 2, or I should say 2 to the power of 3, where 2 indicates the binary value, that is 1 and 0. 3 indicates number of inputs, and 2 to the power of 3 gives 8. 8 gives number of input combinations that can happen. Now this entire thing he has expressed in a form of a tabular form, and that we call it as a truth table. So there are two ways of solving. One is sum of product and product of sum. Sum of product is known as min terms. Product of sum is called max terms. Now here, if you see the min terms, how we are placing it here, this is the truth table. As we have seen, there are total 3 inputs. Only two binary values are there, 0 and 1, and 8 input combinations. If you count from 0 to 7, it becomes 8 inputs. Now, the first one is represented as small. So min terms mean we are representing with small m. So now whatever is written here, if the inputs indicate 0, we are expressing it as, this is 0 means A bar, 0 means B bar, 0 means C bar. And it is expressed with whatever is the first term. First term was 0. So the first row is called as small m 0. So A bar, B bar, C bar. So this is how, in the last class we have discussed more about it. So just a glimpse of it. So this is how a truth table is been expressed, where number of inputs combined together to give a single output. If you see, these are 3 inputs combined together. Since it is sum of product, the first thing what we have to do is to find out a product, and later on we will go for summation. So it is expressed, first we are expressing in terms of product. So all the terms which are present in that particular row is expressed as product. So that is how the entire equations, the terms are being created. So this is a term present in the equation with respect to what is the input combination there. Fine. Now, if you go further, now how to create an equation out of this truth table? We can do vice versa. With that equation, we can get the output for the truth table, or we can go ahead with vice versa. Now here, in this sum of product or SOP, what is the thing that we have to take care is, first thing we have seen is 0 is expressed as bar, step 1. Step 2 is at the output, wherever we are getting ones, we are considering only them. Remember, in SOP or with these terms, min terms, we are picking up only where the output says 1. Where it is mentioned as 0, we are ignoring it. So the first term what we can see here is where the 1 is written. If we go in the same row, you will find it is A bar. 0 means B bar. C will be written as it is. It says A bar, B bar, C. Now next, where is the 1? Next, you will find the 1 is placed in 0, 1, 2, 3, fourth position, that is M4. Right? Remember, this is a fifth position. Since we are starting with 0, it has come as fourth position. So M4 will be, if you look at this, it will be A will come as it is. A into 1 is A. Whereas B, which is with 0, will become B bar and this will become C bar. That makes it A, B bar, C bar. Next is the fifth term, that is M5. You can see here, this is A, B bar, C. So you get the term A, B bar, C. Then if you go to the next one that we have got at the output, you will find in the M7 position. That makes it A, B, and C. So it is expressed as A, B, and C. So what is min terms or what is SOP? We are doing first product and then we are doing summation. So what we have done in the earlier one, we have done the product. And then what we have done? We have done the sum. So this becomes product, then it becomes sum. So it is written as sum of products. That is what we have done in min terms. So now here, if you want to write the equation again, that was one way. So first step, what we have seen, we are expressing our entire input, means 0 is expressed as A bar. In the previous one, what we have seen, after how to take the output, in the output, we will pick up only once. Remember, 0 is not meant for us. Only once we are saying when we are talking about min term or SOP. So second step was, in the output, wherever the 1 was written, we have picked up only those rows to make our equation. Now, that was one way. Now, one more way is there, that wherever we have written the equation, see here, what did we say? If this was 0, this will become M1, M2, M3, then we get M4. So we got it for M1, we got it for M4, we got it for M5, and then we got it for M7. That means we can also express this entire equation with respect to M1, M4, M5, and M7. So instead of writing M1, M4, I'm writing here. Summation indicates sum of all the products, and 1 indicates the term, that is M1. So here, if I'm saying M1, my terms become here A bar, B bar, C. So it becomes A bar, B bar, C, which is M1. 1 indicates the position here. Then if you go for next term directly comes at 4, M4. So here the position becomes, the row becomes A, B bar, C, A, B bar, C. Suppose this is M4, I'm writing here 4. Then we are going for M5. M5, why we have picked up 1, 5? Because it is at the output, it is indicating as 1. So we have picked up only once. Now it has become A, B bar, C. So A, B bar, C, M5, 5 is written here. And then last what we are having is M7. All three are ones. That means it becomes A, B, C, and we are writing 7. So that is how we can write the entire truth table, either with numbers, that is the number that we have got it, that is decimal number, that says 0, 1, 2, 3, 4, and it can be expressed in small m because we are talking about SOP, that is min terms. So now equation can be written in 3 ways, either with A bar, B bar, C, either with M1, M4, M5, or summation of 1, 4, 5. All three are the expressions for Boolean function, and your answer, depending upon the question, can be written in any of the 3 forms. This was all about min terms. Now we will go for next, that is max term. Now, if you compare min terms, we said wherever the ones were there, we have considered only those for min terms or for SOP. What about zeros? Zeros will be taken care by max term. That means if one says min terms, we are picking up equation for min terms. 0 means we are picking up for max terms. That is POS. That is product of sum. Now, when we talk about product of sum, that means we are talking only about the OR function. We are interested only in zeros. Now, how it can be expressed? Here, first step is we are expressing here with respect to capital M Okay. And it can be written as, if you see here, this 0, 0, 0, which was in product in min terms, is in summation here in max terms, and the bar has gone. Whatever was expressed earlier as A bar B bar for 0 and 0 is now expressed as A and B, but no product sign, it's a summation sign. Remember in De Morgan's what we said? If you want to break the bar, you have to change the sign which is present between those two values. So it's the similar kind of thing that we are changing the end. We are just to remove the bar, we are changing the product sign. So that is how it has been expressed, where 0 is expressed as whole variable and 1 is expressed as bar. So this is how you can express your POS, that is product of sum. First, we are doing the sum like we did earlier in min terms. First, we did the variable part. We have just merged them. The min term we merged as product. Here we are merging it as sum. So it will go again in the reverse order. First, we are doing the sum of the row that we have got it. Then we will multiply them with each other. We will do the product of it. Now, if you compare both the sum SOP and POS, it's very clearly mentioned that if min term SOP is expressed only with ones at the output, here it is expressed only with zeros at the output. So if and how the equation is been created, the product and then summation. Here, first we did summation and then we did the product. So what is POS? POS is summation and then product. And capital M we are picking up. In min terms, that is SOP, we have taken care of only ones at the output. Here we are taking care of only zeros at the output. That means if you write this entire equation in the terms of numbers, that means this is 1, M1, this is 4, this is 5, this is 7. So just whatever is left out will become POS. That means 0, then 2, then 3, and then 6. The representation here is, in min terms, it was with summation, and here it is represented as pi. So the basic difference between both of them is, when we are taking SOP, that is sum of product, we are taking product and then sum. When we are doing product of sum, we are doing sum and that product. We are going in reverse order. So that is one way of expression which can be done, which is very easy actually, because even if you have got the equation in a SOP form, you can easily convert it into POS form and vice versa. So to represent this type of equation in POS is one method. Another method that we are having is that we have just made F, that is output, as bar. Now, as soon as you make output as bar, naturally what will happen? All zero, we are making only the output as F bar. So everything will be in a complement. So when it becomes complement, 0 becomes 1 becomes 0. And then we will be writing the equation again in the same form, but again, this time what we are doing, we are picking up only ones. And then you will write the equation in POS form. So if you see, the result is still the same, even the method is different. I prefer to go with this particular method because that helps us to differentiate between SOP and POS. So that this is my personal choice. You can pick up anything that is you find it easy to solve it. So like we said, we can convert with the help of this technique, we can convert any equation to any form. Like either SOP can be converted into POS or POS can be converted into SOP. Now, how will we do that? See, this equation we are having. This is the question we have got. We have solved it in terms of min terms. Now, the question says, convert this equation, this SOP equation into POS form. Now, how to convert this SOP into POS? We just have to do F bar. What we have done, you can see. What we have done is, this was what we have got it as the as an output of min terms. To convert it into max terms, I'm just making it F bar. And I'm just writing the equation that I have got it. So here, if you see the equation, what I'm writing is actually the SOP form, but I'm picking up the output just by reversing. So now I'm not making the equation with F. I'm making equation with F bar. Restore technique is same as SOP, only what we have done, we have changed output to output bar. And we have again picked up the equation in the SOP form. So that gives us this particular equation. Next, to convert it, what we are doing? We are just making whole bar. Remember, we have made it F bar. So if you just try to solve this with entire, to make it F, we will make it double bar. And this entire bar comes to the equation. If you solve it, you will get the output as in a pause form. And this you get the output. So if you see this and this, whatever is left in this equation of F with summation, with SOP, whatever is left out comes as a pause equation. And that is how the conversion happens. But as I said, I preferably go with this particular method to solve the questions because I found it easy. So in various books, you will find various techniques. You can even opt for this one because this actually doesn't create any confusion. So how to remember it? Whatever we have got with SOP, we have got it output as 1. So pause will be everything with zeros. SOP was with product and then summation. Pause is summation and product. Then output is only F. Here also output we have taken F because we have taken zeros. We are not taking bar. So no issues. Then here restore technique is same, that in SOP we are taking zeros as A bar, whereas in pause we are taking 0 as a whole variable. So this is how we solve. In the next class, we will be solving some more questions. So if any, even if some doubt is there, it will get clarified.